So today we are back with 4 challenging problems of IOQM 2021 paper, the very last IOQM paper. So these problems are kind of fresh from the orchard. So the procedure for attempting these problems would be the same. I have written down a problem on your board as you can on your screen as you can see, and then what you have to do is you have to pause the video and give this problem a try. Then after you have tried, you can continue watching the video for a solution or to check your answers. So the first problem reads as follows: let A, B, C, D be a trapezium in which AB parallel to CD and AB is equal to thrice of CD. Let E be the midpoint of the diagonal BD. If area of ABCD, the square brackets imply area of the shape ABCD, is equal to n times area of CD, what is the value of n? Okay, so please give this problem a try, and after you have tried, then continue watching the video for a solution or to check. Okay, so I have made a figure over here. As you can see here, I have drawn CD parallel to AB, and what I have drawn is I have drawn the two diagonals AC and BD because I want to show you an analysis. Okay, let the point of intersection of the diagonals be called O. Now it is then 10th standard geometry to see that triangles COD and triangle AOB are similar. So the ratio of their areas would be the ratio of the squares of their sides. So if CD is K and AB is A times K, where A is any real number, not necessarily an integer, then CD squared by AB squared is equal to the area of COD by the area of AOB. So A square, so area of COD by area of AOB, since they are similar, will be the ratio of the square of their sides is equal to 1 over A squared. K squared cancel, K squared by A squared, K squared cancel, and so it is 1 over A squared. So if this is 1, this would be A squared. Now, since again triangles COD and AOB were similar, then we could have said that OD by OB was equal to CD by AB, which is equal to 1 over A, right? Let me write that down for you. Okay, so if AD measures A, if OD measures 1 unit, then OB would measure A times 1 unit. Okay, so now it is again 10th standard geometry to see that in triangle CDB, we have two triangles CDO and COB whose bases have been divided in the ratio OD is to OB. Therefore, the areas of these two triangles will also be in the ratio 1 is to A, because the ratio of the two triangles whose bases have been divided in a particular ratio have their areas also divided in that particular ratio. So the area of triangle COB would also be A. Okay, and for that same logic, the area of triangle DOA would also be A, right? The base CA of this triangle has been divided in the ratio CO is to OA, and CO is to OA is again from our similarity criteria 1 in the ratio 1 is to A. Therefore, the areas of COA and areas of DOA and COD are in the ratio 1 is to A. Now in our problem, you will see that AB is thrice of CD. So what we can do is, if we take CD to be equal to 1, then AB would be equal to 3. So let us do that. I take CD to be equal to 1, AB would then be 3, then A squared over here, it will be replaced by 9, A, it will be replaced by 3 on both sides. So the area of these 4 triangles is 1 plus 3 plus 9 plus 3, which is 16. Now what our problem reads is that E be the midpoint of diagonal BD. Let E be the midpoint of diagonal BD. So here we have the diagonal BD. So we want the midpoint of this diagonal. So let's say it lies somewhere over here, and I name this point E. Okay. Now what I do is I again apply that theorem that if the bases of two triangles having a common vertex is divided in a particular ratio, then the areas of those two triangles are also divided in the same ratio. So here the bases are divided in the ratio 1 is to 1. D is to EB. Since E is the midpoint, is divided in the ratio 1 is to 1. So the area of triangles CED and CEB would also be in the ratio 1 is to 1. Now the total ratio of CDB was 4, and now each of them has been divided into equal area. So the area of CDE would now be equal to the area of CBE, which will be equal to 2, right? 3 plus 1, which is 4 by 2, is 2. So what we want is ABCD by CDE is 16 by 2 is equal to 8. So N is equal to 8, and that's the final answer. So this problem would have been nearly impossible if you did not know the analysis that the ratios of the triangles which are formed by the diagonals of a trapezium are in GP from both sides in cyclic order. So it is 1, 1 into 3 is 3, 3 into 3 is 9. And if you again go from here to here, it is 1, 1 into 3 is 3, 3 into 3 is 9. Okay, so it would have been extremely difficult if you did not know this analysis. So now I hope that you have noted this down, and you have to think some of the things out yourself also. This is not a problem which is very easy. This is problem from the IOQM, so you have to have a lot of analytical skills and thinking capacity. So you have to think some of the things out yourself also. And if you have any problem regarding any points in the explanation, then do write it down in the comments and we will definitely get back to you. So now it is time for the next problem. The next problem is a simple one, rather simple one. Let ABCD be a rectangle in which AB plus BC plus CD is 20 and AE is equal to 9, where E is the midpoint of the side BC. Find the area of the rectangle. This is a very simple problem, and I hope that all of you will be able to do this. So please pause the video and try. Okay, so now I think that you have tried, so let me give you a solution. So this is, let's say, a rectangle, and what I do is I name the sides A, B, C, D, and as stated, E with the midpoint of side BC. Let E lie somewhere over here, and what I do is I join A and E. So it is said that AE is 9. This is a right angle because this is a rectangle. Now I will make some assumptions. First, let me assume that AB is equal to X, and since this is a rectangle, CD will also be X. Now let me assume that AD is equal to 2Y. Why 2Y? Because I have to divide 2Y into Y and Y over here. So I do not would like to deal with fraction. So what I do is I simplify. You could have also taken this to be Y, and then each of these portions would have been Y by 2. Okay, so that's not an issue. Then what I do is, what is the area then of ABCD according to our assumption? It is length, which is X. It is breadth times length. So breadth is X and length is 2Y. So the area is 2xy. Keep this in mind for the time being. Now let us try to arrive at the expression 2xy by using the data we have been provided. Now given that AB plus BC plus CD is equal to 20. Now what I can do is I can substitute X for AB, 2Y for BC, and X for CD. That is equal to 20. So X plus Y is equal to 10, and let me square both sides. X squared plus Y squared plus 2xy is equal to 100. Now I can all see that that there is a 2xy in this expression, but there are also these two terms which are posing a problem for the time being, X squared plus Y squared. What about them? So here we see that it is given that AE is equal to 9, and this is a right angle triangle. This triangle which I am talking about is a right angle triangle, triangle ABE, and X square plus Y square is equal to 81 by using Pythagoras theorem in this triangle. So 81 plus 2xy is equal to 100. From here, 2xy is equal to 100 minus 81, which is equal to 19, and that's the answer. Okay, so this was a very easy problem for IOQM, and I hope all of you had got this correct. And even if not, there is no point to worry. Practice makes a man perfect. So welcome to the third problem. The sides x and y of a scalene triangle satisfy x plus 2 del by x is equal to y 2 del by y plus 2 del by y, where del is the area of the rectangle. If x is 60, y is 63, what is the length of the largest side of the triangle? So this problem is deceptively simple. So it looks very daunting when you see it for the first time. But if you just go on having some faith in the problem, then you will find out that this problem is very simple. Now let me give you a solution. So here it is given that x plus 2 del by x is equal to y plus 2 del by y, and it is given that x is equal to 60 and y is equal to 63. You just substitute these values. Then you transpose 2 del by 63 to the LHS. So it is 2 del 1 by 60 minus 1 by 3, and that is equal to 3. This is equal to 2 del e multiplied by 60 into 60 is equal to 3. That implies 2 del is equal to 60 into 63. So delta is equal to half into 60 into 60. Okay, so now this is a very striking situation because 60 and 60 are sides of a triangle, and if the area of a triangle is half into one side into another side, then this implies that one of the sides is a base and other side is perpendicular to that side. Okay, now 63 can be the base. In that case 60 would be perpendicular, or 60 can be the base. In that case 63 would be perpendicular. That implies that the two sides of this triangle, which measure 60 units and 63 units respectively, are perpendicular to one another, perpendicular to each other. Therefore the triangle mentioned is a right triangle. Why? because area of the triangle is half into one side into another side. This implies that these two sides must be perpendicular to each other. Okay. Then what we can do is we can simply find the hypotenuse. So the length of the largest side, which will be the hypotenuse, and I call that L, is root over 60 square plus 63 square, which is nothing but equal to root over 7569, which is equal to 87. And that's the answer. So I told you that it was a deceptively simple problem. Initially it looked daunting, but this little analysis over here was the need of the hour. Right? So now let us go on to the last problem for today. And this problem deviates from geometry to sequences and series. This is the last problem, and it reads as follows. If summation k is equal to 1 up to capital N, 2k plus 1 divided by k square plus k whole square is equal to 0.9999, find the value of capital N. So please give this problem a try and again continue watching the video for a solution. So let me provide you with the solution. So summation k is equal to 1, 2k plus 1 by k square plus k whole to the whole square is summation k is equal to 1 up to N, 2k plus 1. I take k common from this bracket over here. So it is k square outside and k plus 1 whole square inside. And then I add k square in the numerator and also subtract k square in the numerator. And what I do is I distribute the denominator between these two. So I've jumped a couple of steps, and I strongly invite you to work the steps in between out yourself. Okay, these small practices will help you to alleviate your understanding and thinking capability a lot. So now what I do is I write this k plus 1 whole square by k square k plus squared minus k squared by k square k plus 1 whole square. Now notice k goes from 1 to n, and these are natural numbers, so k plus 1 whole square cannot be negative, or k plus 1 whole square cannot be 0. And secondly, here you can say that k square can also not be 0. So I am left with summation k is equal to 1 up to n, 1 by k square minus 1 by k plus 1 whole square. And that is equal to 0.9999. Right? So now let me kind of try to expand this by putting some values, and then we will see something interesting. So I put k is equal to 1 in the beginning, so it is 1 by 1 minus 1 by 2 squared. Then it is 1 by 2 squared minus 1 by 3 squared. Then it is 1 by 3 squared. These are consecutive terms. This is 1 by 3 squared minus 1 by 4 squared. 1 by 4 squared minus 1 by 5 squared. And this continues so on up to 1 by n squared minus 1 by n plus 1 whole square. And that is equal to 0.9999. And I can cancel terms like this. So what I am left with is 1 plus minus 1 by n plus 1 whole squared is equal to 0.9999, which implies that 1 by n plus 1 whole squared is equal to 0.0001, which is 1 by 10 to the power 4. Then what I can do is I can say that n plus 1 whole squared is 10 to the power 4. I have just taken the reciprocal on both sides. Then n plus 1 would be 10 squared and n would be 10 squared minus 1, which is 9. That's the okay. So with that we come to the end of today's video. I hope you enjoyed this session very much. If you have any doubts regarding any of the solutions in this video, or if you want to challenge any solution in this video, then do reach out to us in the comment or in the Telegram groups. See you in the next video. Bye bye.